Hi, now I'm going to talk you through the toolkitting of lesson 53 and look at a bit of the CYUs. So what we want to toolkit here is just the definition of a differential equation. So a differential equation is any equation that, that did not go very well. All right, I'm not going to do that. So a differential equation, any equation that contains a derivative expression. So we say that dy dx is first order. We could also have f prime of x is first order. D squared y dx squared is a second order derivative. Differential equations may contain the original function. In that case, we would call it an implicit relationship, or be written in terms of the independent variable only, which would be explicit. And if we see this word proportional, then dy dx is going to be a multiple of y. So we've got a multiple of the dependent variable. And k is my constant of proportionality. So your first CYU talks about that. Oh, goodness. It says number of fruit flies increases at a rate proportional to the current population f. So my differential equation is going to be df dt, because I've got a rate. And even though they don't explicitly say time, it's how fruit flies are changing over time. And it's going to be a multiple of the fruit flies. I'm going to come over here to this one. We've got the weight of a baby bird initially, so when it's born, is 20 grams. B of t is the weight of the bird t days after it's first weighed. And our differential equation is proportional in terms of the weight of the bird. So at what rate is it changing when it weighs 30 grams? Well, I want to highlight to you how we would write this. So in this case, because we don't have b prime of t, we have db dt, I'm going to stick with that. And I'm going to draw this straight line and write b equals 30 to show that I'm finding db dt when b is 30. So that's going to be 1/5 of 70. Which is going to be 14 grams per day. Doing that again, dB dt, when the bird weighs 90 grams, is going to be 1/5 of 10. So that's going to be 2 grams per day. So notice, the more a bird weighs, the slower its weight is changing. So that makes sense. When you're a baby, you gain weight rapidly, and then as you get closer to adulthood, hopefully you stop gaining weight so quickly until you plateau at your sort of adult weight. All right, so what can you say about the rate of change of bird's weight as it gets closer to adult weight? That's what I just described. So put that into your own words. This graph cannot be the weight of the bird B. This part makes sense that we plateau at an adult weight, but over here, this says that our weight grows slowly in the first few days, and that's not true. We gain weight quickly at the beginning. All right, this last one is choose which of these are solutions to this differential equation. So this is a second order differential equation because it has a y double prime in it. I'm going to do the first one for you and let you figure out the rest. You can check your answers on our solutions document that I had open a few minutes ago. But this one, we've got y is e to the x, so y prime is e to the x. Y double prime is also e to the x. So y double prime plus y, does that equal 0? Well, e to the x plus e to the x does not equal 0, so this is not a solution to this differential equation. All right, you can keep on going with that, check your answers, and of course, reach out to us with questions.